guys. Today we are on 12.5, other rules of exponents. So 12.1 through 12.4 all drew on your rules of exponents that were taught in chapter 4. This lesson is a continuation of chapter 4, so introducing more exponent rules for your arsenal. So starting with the yellow box, rules of exponents, they're going to introduce 2 new rules. We'll do some examples, and then they're going to introduce a third at the end. I wrote all 3 out here for me, and I recommend that on a piece of paper you write out your rules as well. That way you can use that as you are going through your own practice problems. So, to that yellowy box, rules of exponents. Our first rule is the power of a product property. So, just unpacking that, a power is already your exponent, so a power, an exponent of a product. So the exponent of multiplication property. Words. To find the power of a product, find the power of each factor and multiply. And we're given this little algebraic thing. AB raised to a power of m. And then they say that is equal to a raised to the power of m times b to the power of m. So, when you have multiplication on the inside of parentheses, and then an exponent on the outside, your exponent has to get distributed to each part of the terms on the inside. And then they give you an example. They say 3 times 4 is being raised to the power of 2. And so, what you do, take your 2, distribute it to your 3. So 3 squared times 4 squared. 3 squared is 9. 9 times 4 squared is 16. Equal to 144. Notice that if you had done 3 times 4, you would have gotten 12. 12 squared is also equal to 144. So our rule is, for the power of products property, take your exponent on the outside and distribute it to everything being multiplied on the inside. And then the second example, or second rule they give us, is the product of quotients property. Quotients tells you division, property tells you, or not property, power tells you have an exponent. So words, to find the power of a quotient, so the power of something being divided, find the power of the numerator and the power of the denominator and divide. And then they give you a over b is raised to the power of m. And same thing with the other one. Basically, they're just saying, take your power and distribute it to both your numerator and your denominator. So a over b raised to a power of m is equal to a to the power of m over b to the power of m. And then the number example is 4 over 7 squared, which just means distribute 2 to everything on the inside of your parentheses. So you're going to have 4 squared over 7 squared. Your book actually uses 5 instead of 2. Just replace 2 with 5 and you have the same thing. Alright, let's look at example 1. Example 1, already wrote that. We have a, 2x is being cubed. So first we need to ask ourselves, what rule is this? Because it's multiplication with terms on the inside. We have the power of a product, so AB to the power of m. That means take your 3 and distribute it to everything on the inside. So starting with your 2, 2 to the third times x to the third. 2 times 2 is 4, 4 times 2 is 8. So 2 to the third is 8. X to the third is just x to the third. So 2x to the third is really 8x to the third. B, we have negative 5y being squared. Same as the one above, we have power of a product, So take your 2, distribute it to everything on the inside. We have negative 5 squared times y squared. Negative 5 times negative 5 is going to be a positive 25. 25 times y squared is just 25y squared. And so now we have solved example 1, A and B, using the power of a product. Let's look at example 2, finding powers of a quotient. We have m over n raised to the 7th. Our power of a quotient tells us take our exponent and apply it to everything inside of our parentheses. So that case, it has to go, oops, not in the second, to both m and n. And then you just rewrite m to the 7th over n to the 7th. And there's nothing else we can do to simplify it. So that is our final expression. For B, we have negative 3 over k, all being raised to the power of 5, I believe. Yep. The power of quotients says take your 5, or your exponent, distribute it to everything on the inside. So now we have negative 3 raised to the 5th over k to the 5th. You can use a calculator to do negative 3 to the 5th, that's okay. And when you do, you're going to get negative 243 over k to the 5th, and that's your final answer. Very good. And now we have one last rule for today's lesson, and it's called rules of exponents, power of a power property. So our very last one on the board. The power of a power means you have an exponent, so a power of a power. So you're taking that exponent and you're raising it to a higher exponent. To find the power of a power, multiply your exponents. Remember when you're multiplying exponents, so x to the n times x to the n, you're adding it. But when you have a power of a power, you're finally multiplying your exponents. Let's look at what that means. So they tell us, if you have something that looks like this, a to the m, that's then being raised to an additional exponent, so a is being raised to n, but this entire expression is being raised to n. When you have a power of a power, you multiply your exponents. A is then equal to m times n. And it's again important to distinguish that when we have a to the m times a to the n, where you just have two expressions being multiplied together, you add your exponents, a, m plus n. But when you have a set of exponents being raised to a higher exponent, that's when you multiply. So the example they give us then, still in the definitional box, is 7 squared being raised to the power of 3. Because you have 7 squared, a power being raised to a higher power, you have a power of a power, so that just means you multiply. 7 2 times 3, so it becomes 7 raised to the 6th power. Let's look at example 3. We'll leave this on the board. A, we have 10 to the 3rd raised to the 3rd. So 10 to the 3rd, a power being raised to a higher power. We're told to use our product rule. That just means we multiply these two exponents together. 10 raised to 3 times 3. 3 times 3 is 9. 10 to the 9th. B, we have p to the negative 4th being raised to a power of 5. Our product rule says if we have a power to a power, we multiply. So we have p raised to negative 4 times 5. P is equal to the power of negative 20, or p over negative 20. Pull back on your knowledge from chapter 4. We cannot have a negative exponent. A negative exponent is the same thing as your original expression, just over 1. So our final example here, or our final answer here, isn't p to the negative 20th, but 1 over p to the 20th. And that's our final answer. Alright, last one, example 4. Using properties of exponents. The world's tiniest book. The square pages in the world's tiniest book are about 2.5 times 10 to the negative 3rd meter on each side. What is the approximate area of one page of this book? To find the area of one page, use the formula for a square. Area is equal to the side squared. So example 4. We have area is equal to a side squared. They told us the side of this particular tiny book is equal to 2.5 times 10 to the negative 3rd, and we're told to find the area. Well, to find the area, we just square the length of our side, which means we now kind of have a combination. We have the power of a product, and we have the power of a power. So step 1 is we need to distribute this 2 to everything inside of our multiplication. So area is now going to be 2.5 squared times 10 to the negative 3rd squared. 2.5 squared is basically the same thing as 25 squared. 25 squared is 625. Put in your decimal point and you get 6.25 times 10 power of power, so times 10 raised to the negative 3rd times 2 to the negative 6th. So the area of this book is equal to 6.25 times 10 to the negative 6. You don't have to worry about the fact that this exponent is negative because we're talking about actual dimensions, measurements, and so we're good to leave it negative. With that, you may begin your homework.